All right, now we are going to take a look at a couple of rational inequalities. And like polynomial inequalities, we're going to do a sign check and then give the solution using interval notation. We do have to be careful about values that make the rational expression undefined, where we might have a vertical asymptote or even sometimes a hole in the graph. We don't want to include those values of x. And so it's a little wrinkle. That's the difference between polynomial and rational inequalities. So let's take a look at an example. Again, I want to start by getting 0 on one side of the inequality, and hey, we've got the 0. That's good. If I didn't have a 0 here, I want to subtract to get everything over on one side. And we'll look at an example of that in the next problem. So how do we proceed here? Well, when we look at this rational expression, there's two things I want to know. I want to know, where is it undefined? Which we don't have a problem with that with polynomial inequalities, but we do with rational inequalities. So is there any value of x that will make this expression undefined? Does anyone see a value of x that will make this expression undefined? Well, I hope you're saying when x is 2. And the reason is, when x is 2, the denominator is 0, we're dividing by 0, and that's not defined operation, right? That's sometimes x equal 2 is what we call restricted value. Okay. And in fact, if you remember our analysis on rational expressions, if I plug in x equal 2, the bottom is 0, but the top is not 0, and that's going to give rise to a vertical asymptote. If we're looking at the graph, we're going to see a vertical asymptote. Also, this is equal to 0 when x is what? When is this equal to 0? Well, not when x is 2. Again, division by 0 does not equal 0. But when 14x minus 2 is 0, when the numerator is 0, we're going to have the output be equal to 0. When is that the case? When is 14x minus 2 equal to 0? Well, if I add 2 and divide by 14, I get 2/14, which is 1/7. So it's going to be when x is equal to 1/7. So those are our two important values we need to put on our sign check. Which one's smaller, 1/7 or 2? 1/7. Okay, so I'll put the 1/7 to the left of 2. And I like to do this again. Now, when x is 1/7, this expression on the left, again, this rational expression, is going to be equal to 0. So I'll have 0 divided by whatever 2 minus 1/7 is, right? That's 13/7. So 0 divided by 13/7 is 0. That's the output to this rational expression. But what is it when x equals 2? It's not 0, it's undefined. And I put a u there to indicate that. And this is real important. These values will not be solutions in the interval where it's undefined. So 2 will not be in the interval, ever. So don't include 2, whatever you do. Okay. So what do we do now? Again, we do our sign check. What's the sign of this rational expression between and beyond these values? So I look at a number less than 1/7. What's a number less than 1/7? Well, 0. I can plug in 0. If I plug in 0 over here, I get 0 minus 2. The top would be negative 2. 2 minus 0, the bottom would be positive 2. A negative 2 divided by a positive 2 is negative 1. So it's negative. What about between 1/7 and 2? What's a number between there? I'll try 1. 1's in between there. If I plug in 1, I get 14 minus 2, which is 12. 2 minus 1 is 1. I get 12 divided by 1, I get 12. It's positive, though. That's the important thing. If I pick a number bigger than 2, like 3, what happens? Well, 14 times 3 minus 2, that's a positive number. 2 minus 3 is negative 1. A positive divided by a negative is negative. Okay. And there's my sign check. So now I can answer the question. I go to the inequality. What am I looking for? When is this rational expression less than or equal to 0? When is this rational function less than or equal to 0? So I'm looking for when it's negative, and I see two intervals where it's negative. So everything less than 1/7. So from negative infinity up to 1/7. Do I include 1/7? I'm including, right, less than or equal to 0. I'm including where it is 0, and it is 0 at 1/7. So that's a bracket on 1/7. And then I want to include the other interval where it's negative. Okay. Well, that's everything greater than 2. Do I include 2 like I included 1/7 because it says less than or equal to? Do I include 2 as well? No. 2 is not going to give us a value of 0. It's undefined, right? If I plug 2 into this expression, it's undefined. I never want to include 2. So I have to keep the parentheses on 2. So you've got to be real careful to clearly show brackets and parentheses on these answers. And then everything up to infinity. So there's my solution. There's my solution. All right, let's look at one more. This one is a rational inequality, but you'll notice this time we had 0 on our right-hand side there. This time we do not. And so what are we going to do in this case? I have to get this to be 0 here. So what do I need to do? I need to subtract 1 from both sides. 1 minus 1 being equal to 0. Now, there's my inequality. The problem with doing our analysis on this inequality is it's not really in a form that's easy to deduce, for instance, when this expression is 0. And so what we like to do is just write this as one rational expression. And how do we do that? So do you remember how to do that? I'm going to rewrite this in order to subtract. I'm going to rewrite this over at the least common denominator, which is just 3 minus x. So it's pretty easy here. What am I going to do? I'm going to subtract 1 in the form of what? 3 minus x over 3 minus x. How much is this? This is equal to 1. But I have the same denominator now. So I can subtract, and be real careful. Up top I have 3 plus x minus the quantity 3 minus x. I'm going to be real careful, right, over the common denominator of 3 minus x. So I just combine these two by subtracting. You want to be careful, though, to do what? To use the distributive property here. Don't forget there's parentheses around these numerators and denominators when we write this, this horizontal line. When we're dividing this, you have to remember that. We don't write the parentheses, but there are parentheses there. So what do we get then? I get 3 plus x, what? Minus 3 minus minus plus x. And what happens here? Simplify up top. 3 minus 3 is 0. What's left up top here? X plus x is 2x. And so we can now rewrite the left-hand side as simply 2x divided by 3 minus x. And now I can quickly tell, with that, I can quickly tell when is this going to be equal to 0. This will be equal to 0 when x is what? When will this expression be equal to 0? When x is 0. Some of you might have said when x is 3. Well, you'd be wrong, because when x is 3, I'm dividing by 0. In fact, what do we know? This is undefined when x is 3. Right? Division by 0 is undefined. So when I go to the sign check here, x is 0 and x is 3, I know at 0 the rational function will be 0. At 3 it's undefined. I do my sign check again for values less than 0. If I put a negative number in, like negative 1, I get negative 2. 3 minus a negative 1, 3 minus a negative 1 is positive 4. So negative divided by a positive is going to be a negative number. Pick a number between 0 and 3, like 1. 2 times 1 is 2. 3 minus 1 is 2. 2 divided by 2, positive 1. And if you plug in a number bigger than 3, and I'll let you do that, if you plug in 4, you're going to get a positive divided by a negative. You're going to get a negative. Okay. So now we go to the inequality, right? What are we looking for? When is this rational expression greater than or equal to 0? So we see that when it's positive, it's greater than, and we're going to include 0. So that means what? I'm going to include 0, Am I going to include 3? No, it's undefined at 3. I'm not going to include 3. So my solution is bracket on the 0, all the way up to 3, exclude 3. Here's my solution. Okay, so we'll stop here, and that's all we have on rational inequalities.